All right, I think we're live. Professional audio in audio settings. What does this mean? Enable original sound from microphone. In meeting option. Huh, Zoom gave me this option to do, what does that mean? Professional audio. I think we're okay with amateur audio. Everyone can hear me all right, right? We'll be fine. All right, I think let's get started. Welcome to day 4. Congratulations, you've made it through 3 days of the programming, and you're still back for more. Like, really, this is like something to celebrate. And I think yeah, I hope everybody, I thought Ariel was coming too. She might be on the way. Oh, Ariel, you're here. Hey.
Yeah, I'm here. Yeah.
Cool. Well, yeah, this is the end of week 1, and we have 3 more weeks of just basic JavaScript. Today, if we do want to, for our activity, we could jump back to the browser if you're sick of all this console stuff, and we could start, poking around with, what JavaScript can do in the browser if you're curious. We could also review things that we did earlier this week. Anything you want to try again. It's really, we're gonna have a lot of stuff to get through, but I want to leave some time today just to kind of relax a little, do some stuff that's reinforce some stuff that you might want to ask more about. So, and we can look at some of the homework if we want. But like I said, I think shortly before class, we're not going to go over that WizWaz problem until next week, just to give everybody a chance to really, really try to solve it. Don't worry if you can't. It's a tricky one. It's going to be, it's tough to just go from basically, we were doing very basic fundamentals to like solving like your first real problem. So, try your best this week and don't worry about it too much, but we will go into it on Monday, and then we can, start talking about some of the ways that the strategies, because I've already seen in like, we've only had a couple submissions, but I've already seen more than one, I think 3 different strategies to solving it. And it's pretty cool when you kind of can break down how you go about trying to solve it. So that should be interesting, but we're going to do that next week. Carolyn, you are wondering about assignment 20. I will look at that really quick. Which one was that? That was, that's the first one?
No, it was the seconds in a year. And you had gone through that yesterday, but I had started something on my own and I sent it to you in Classroom, Google Classroom. I sent you a private message, and I may have sent it to you on Slack as well, just to see if I was even close. And that's without referring to yesterday's class. So
I need to figure out where these private messages in Google Classroom even are. I'm not the biggest fan of this Google Classroom, but I don't know. I got an email notifying me that for sure, but I can't find it. So try just submitting whatever you want, and you can submit more than one over and over if you want, like submit
right. When there's 2 separate parts, you can submit your work.
Okay.
And then you can add comments for the instructor.
Okay.
So I don't know, but instead of doing that, then I can just direct message you on Slack or something.
Okay. Yeah, just direct message me on Slack. That's the easiest way. Like I have Slack up like basically every day. Yeah. So even if I don't see it right then, I'll probably get the message by sometime that day, and I'll try to respond like the same day if I can. So
I don't even know if I was even close. And, and I know what you did in class yesterday ended up being kind of different, but I had written this code before that. Yeah. So, I just want to see if
a lot of these are open-ended too. And remember, like, one of the important takeaways I wanted to get, everybody to kind of understand right at the start of this was that, yes, I mean, most problems are like that, where there is not like one right way to do it and a wrong way to do it. You know, there are like better and worse ways in many ways. Like sometimes it's hard to even tell which way is better between two ways. And, you know, a worse way is fine. If it works, it's still fine. Like the you know, the conversation of whether it's the best way or a better way is sometimes just academic. And actually that's a problem that in my job that programmers have all the time, is that we waste a bunch of time. Like, gee, is this really a better way, or is this a better way? Like, it doesn't matter. What matters is that it works or it doesn't really. So if it works and you print the number of seconds in a year, it's hard to argue that like there's anything wrong about that, you know? So anyway.
Sorry about that background call.
That's
The
fine.
last couple days, I'm getting alumni, we want your money calls from University of Nebraska. It's like,
Oh.
if you even go a semester somewhere, they want your money. It's been a long time since I lived in Nebraska. Anyway, that's what that noise was. Sorry.
Yeah, they're probably fine. You probably don't have to give them money.
I think we'll be all right.
Yeah.
The football program helps.
Yeah, they make a lot of money on football. Okay. All right. So let's get right into it and do some slides today. We got a bunch of stuff, and it's gonna be a bunch of stuff. So let's strap in, get ready, calm down. Let's go. Let's go. Okay. 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 I'm sharing screen, right? We have, and everybody has the slide link, I hope. Karen, if yes. All right.
Yes, she dropped it in the chat.
Cool. Okay. So today we're going to mostly be talking about JavaScript types. So don't worry, we're not going to talk about TypeScript stuff. We're not going to get into any of that weird NPM stuff today or any of that other stuff. We're just talking about what the JavaScript language itself considers the types of variables. And then we're going to talk about the functions that we got a little peek at yesterday, at these kinds of ways to package up your code and organize it so that you can make more complicated programs and still keep track of everything. So JavaScript types are things you've already seen mostly. Now, this keyword, this var keyword, you haven't seen this yet. We haven't even mentioned this. This is actually the old way of doing both.
Karen actually taught us var.
Oh, okay.
She said that it's a legacy and they use let now.
It's an older way. I didn't even bother saying it because it's pretty much never recommended. It's always has the same kind of behavior as let. So it never lets you make something that can't change. Everything is mutable, which is like which means it's harder to safeguard certain parts of your program against like stuff being changed. There is one other difference we'll get into in that it's function scoped, not block scoped. I don't know if you remember this, but don't worry about that right now. var is the old way. I just started it out here just so you can see. You might see this in code if you go, if you're in a job and you're working on some code, there will probably be some vars there if it's older code. But this is sort of the newer style. And in this example, the result is the same. So the first type obviously is this number, the number 1, the number 2. These are arithmetic numbers. And the thing about JavaScript that makes it different from some other programming languages like C++, I don't know if you've ever heard of C++ or Python, is most of those languages have two different kinds of numbers. They have, check the chat real quick. Oh yeah, var is still everywhere. I mean, it's an older code. It's all over the place. And if you are, if you're running an older browser, some of the older browsers might not even recognize let and const. But I think pretty much everybody's normal browser these days, and definitely all of the ones on your computers, have support for let and const. So yeah. Anyway, other programming languages that are not JavaScript, they often have two different kinds of numbers. So like one, just by itself, would be what's called an integer type. And that means that it can be 1, it can be 2, it can be 3, but it can't be 1.5. It can't be 1.5. It can't be 2.375 or whatever. And then the numbers that have decimals in them are what's called a floating point number. And in a lot of other programming languages, those two kinds of numbers are completely different types. The language actually understands them to be different types. And sometimes it will let you convert between them, but sometimes it'll say this has to be, this has to be an integer type. JavaScript has really nothing like that. It only has one type of number. It's just called number, and it really effectively is a floating point. It's actually a super large floating point number, which can store more precise decimals than a regular floating point. So it's a decimal number. It works with decimals. Every number in JavaScript can be a decimal number. And, we've seen this, you can use the plus operator to add them. You can do all the arithmetic operators. The star asterisk is a times, the slash is division, the dash is minus. And then obviously this assigning it to a new variable so that we can log it. That's something you've already seen too. But to illustrate like the behavior of numbers a little, let me just show you a little bit about what the numbers do. Let's see. No. Oh, and I still have this background. Let's see. Go to theme, dark plus. Okay. I'm just gonna keep. I'm gonna work in the. I don't have like example code for today, so I'm just gonna work in the. Let's do. I just want an empty file, so I'm actually gonna go Control click right on module 4 and say new file. And I'm going to call this file scratch.js. So just make a brand new file. And then to make sure I have a terminal in the same place, I'm going to do Control click on module 4 and open that in integrated terminal. So we're outside of any of these day folders. We're just in the module 4 folder here. And then my Scratch has any code I want to write for my examples. So you can follow along if you like. You could clear out one of the other files if you'd like. There is a W6 weekend. This is the weekend assignment. I've committed that to GitHub. So if you want to go to GitHub desktop and fetch again. Now see, I have my new Scratch file here, but it's okay. It doesn't mind that I have a change now because it doesn't interfere with anything else. So you can leave that if you have that and fetch. And then, if you didn't already open the code base and make this change, there should be that open in Visual Studio Code button right around here, and you can get to Visual Studio. So just a review of that again. But once you're in here, we are in the module 4 folder. We have a new file. Again, Control click here. You can make a new file right here. We can open it here, and then we can open the terminal in the right folder by Control clicking module 4 again, and the open in integrated terminal. And you're in the right folder if your prompt says module 4. So if I do scratch.js, node space scratch.js. It doesn't do anything because I have no code in my file yet. But if I do 1 + 2, these are two numbers in JavaScript. it's still not going to do anything because remember from yesterday, this is just an expression. It doesn't tell the computer to really do anything. And because we're running this file, it doesn't print anything because we haven't told it to print this expression. We've just said, here's an expression. And the computer says, okay, and it doesn't do anything with it. So you won't see anything even if you run this. But if we do console.log, then we're going to see it printed. And it's the number 3. Now, what'll happen if I do 1 divided by 2? In some programming languages like C, or I don't know about Python. I think Python will do the same thing as JavaScript here, but in some programming languages, it will say 1 is an integer, 2 is an integer. It will do the division, but it will round it down to the nearest integer. It will say, well, both of these are integers. And the result of this is 0.5 because it's 1 divided by 2. But because these two are integers, a language like C would say, well, the result of this has to also be an integer. And 1/2 or 0.5 is not an integer. And I need an integer. So what it does is just chops off the decimal part and it would return 0 actually in that case. In the C language, 1 divided by 2, just like this, is actually 0, which is very weird. In JavaScript, it's a little more intuitive. If you say 1 divided by 2 and we run this, we're going to see 0.5, which is what we expect. And this works for anything. You can say 0.5 plus 1, and it doesn't care. You can mix and match. It doesn't mind that this one is or is not an integer too. It treats everything basically like it would treat a decimal. So you get some arbitrary amount of decimal precision, and it will do mostly what you think. Now, if you do 1 point and then just mash a bunch of numbers plus this, I don't think it's going to print the exact same thing. Yeah. So here, if you can see what it prints out is actually 8, 4, 7, 5, 6, 3, 4, 8, 5. Okay. 7, 6, 3, 4, 5, 8. And then JavaScript prints a 9 right here. And that's because there is a limit to how many decimals that a JavaScript number, a normal number, can hold. It's basically however much data that you can put into a 64 bits of the computer bits. Each number in JavaScript has only 64 ones or zeros inside down, deep into the computer that are used to store it. And there is no way to have all of this detail stored into those 64 bits. So it really just gets the nearest result. So that's something to watch out for. If you have like a very long, decimal that you really, really need to be very precise, or even if you do something like, you could say math with a capital A, math.pi. Oh, it's both capitals, I guess. .pi capital. This is like the value of pi. This is the little squiggle character that from math class, and this in real math, this has infinite decimals. This just pi goes on forever, but JavaScript will only be able to store this much of it. So it goes 3.14159.265.358. 9793, and then it stops. There's no more detail in JavaScript's understanding of the pi number because it has a limit on how much data it can put in a number, if that makes sense. And this is something you have to watch out for because I forget the exact, there's one tricky thing you can do with some numbers. JavaScript, it's like 0.3, let's see. Oh, here we go. Yeah, this is a fun one. I think you can do 0.1 plus 0.2. Now you would think this is going to be 0.3, but if I'm right about this, it's going to get it totally wrong, and it's going to say 0.1 plus 0.2 is 0.300004. So it's almost right, but it's not exactly right. And that's because of the internal way that JavaScript stores each of these. It only has 64 bits for this, and it only has 64 bits for this. And it's storing them in a way that this one doesn't turn out to be exactly 0.1, and this one doesn't turn out to be exactly 0.2. And normally it's fine. You don't notice it, but if you do something very particular like add these, you get a weirdly different result. So it's bad news. JavaScript numbers are not perfect, basically. They are simulating the behavior of numbers, or the best behavior they can efficiently do with their 64 bits of data for each number. And usually this won't matter at all. Usually you're not going to be really adding these two things. But I actually don't remember a single time that this exact kind of bug in JavaScript has gotten me. Actually, no, I know one where we had very detailed like fractional settings for something at work, and it didn't match what was on the server. The server had one number and the JavaScript would show another number, and it's because the decimal in JavaScript, or the floating point number in JavaScript, couldn't represent all of the detail of the server's number. So it's uncommon to see this kind of thing. It's just something I want to call out, because this is one weird part about JavaScript numbers. Other than that, though, all the normal arithmetic works. You can just use it like a calculator. Yeah, here's some other weird ones. Let's just paste these in. Okay, so 200.3 times 3, that should be 600.9, right? Because everything, it's times 3. But it's going to be 600.90001. Okay, very weird. 1 divided by 0 in JavaScript is not error. It's actually the word infinity, which is a little odd. -1 divided by 0 is negative infinity. But 0 divided by 0 is not a number. So there's some weird things. And you can literally say like infinity plus 2. I think that's also infinity. That's technically a number value in JavaScript. Very strange. Infinity plus 2 is also infinity, because you can't get more infinity than infinity. This is how the JavaScript people have decided it should work. It probably bothers a bunch of mathematicians, but this is what it does. Infinity minus 2 is also going to be infinity. Negative infinity times -1, I think, is going to be positive infinity. Yes. So some weird little quirks there about the numbers. Most of the time, you're not going to be messing with this kind of stuff. But, you know, if you ever see the word infinity, well, you know, you probably accidentally divided something by 0. It's not an error in JavaScript. In some languages, dividing a number by 0 is an error. In JavaScript, it'll just say, okay, that's infinity. I know what that is. So a little strange. Okay, those are numbers. There's not much else to them. Strings, we've also seen strings. You can do them with single quotes. You can do them with double quotes. And I think we've seen this new one where you can do them with these backticks. And you can do what's called interpolation, to drop a variable in the middle of a string without having to do that plus. We've seen this method. here is interesting because we want to put an actual quote character in the middle of our string. And if you did this without the slash, I'll show you this example. If you take away the slash, see how it's colored orange, and this thing is colored orange too. If you take away the slash, it's going to error now because it thinks you're ending the string with this second quote. And then it's like, well, what's going on here? This doesn't really make any sense. What's that stuff? So in order to tell it, no, I want the quote character inside my string, don't end the string, keep going. You have to put a backslash before it. And this is called escaping the character after it. This is a common in a lot of programming languages. You put a backslash if you want to make sure this character is not interpreted as anything but the quote in the middle of the string. And yeah, you could put double quotes here. You can also put double quotes here, and then you don't actually have to escape it because the start was a double. It's not going to end here because it's not a double. But anyway, when we print this, we concatenate those two strings together after we've assigned them here. We're going to see hello's world. The space comes from right there. And the new way, the interpolation way, we have world here, the space comes right there, and then all of this gets substituted by the value of this variable place, which we've already assigned this string world. So when we see this, when we log this, we'll see hello world. So these are all the, the different variations you might see on strings. Okay, Booleans, these are the trues and falses. And this here is the AND operator. We saw this the other day. So, whoops. Okay. If you assign if you assign true to a variable called X, you assign false to a variable called Y, and then you make a mutable variable that can change, and you assign the value of X and or just Boolean and. This is you just say and normally. Somebody did part of the homework with a single ampersand, and this is actually another operator in JavaScript, and in this case it will work the same. But for other things that are like truthy and falsy, if you remember, we were talking about, not literally true and false, but, the number 1 is truthy. For other things, this is going to work differently. And it's usually going to work in a way that you don't want it to, or that, you don't expect it to work. So I would pretty much never, until you know exactly what this is about, and we're not going to really go into it, you're not going to need this, and you pretty much always want a double ampersand for and, or a double pipe character for the other opposite one, the or. And that pipe character is right below the delete key. You have to do shift, and then it's the same as the backslash key. And there's 2 of them. So we make this mutable variable z, we assign it X and Y, so that's true and false. And if you remember, I mentioned the and operator in the middle of this expression, it turns this whole expression into one true or false value. And it's only going to be true if both X and Y are also true or truthy. In this case, Y is false, so this whole expression will evaluate to false, so Z will be false. And in the second example, we're reassigning to z because it's mutable. It has this let we can reassign to it. And this is the opposite. This is if x is truthy or if y is truthy, then the whole expression will evaluate to true. And because x is true, then z will be true. So the first time we should see z be false. The second time we should see z be true. False, true. All right, let's pause. Take a break, take a breather. This is a lot of information. We're going in very, very granular detail about this stuff. These are the ones you've already seen quite a bit of. You might be fairly comfortable. A lot of this, like the rules of this and the rules of that are like, oh man, somebody's car alarm is going off. I hope you can't hear that too loud, but you know, being able to explain the exact rules of this stuff is actually something I wasn't very good at a while back. Like it took me a couple tries of teaching this stuff to be able to like kind of just comfortably explain this. It's not stuff that you're going to really learn, like you're going to be able to say what I just said back to me. It's stuff that you'll kind of get a sense of. You understand that the and operator is how you check that both things are true. And this is how you check that at least one thing is true. And, you know, through using them, you'll get more comfortable with them. Yeah. Okay, everybody, I see people on to the next slide. So I'm going to, oh, it's Karen. See, I can see which slide you're looking at, Karen. You're getting ready for fielding the questions about the next one. Okay, so these are some special types. We haven't really talked much about these, but JavaScript has two different kinds of like nothing here types. One of them is null, and one of them is, we saw this before, undefined. This one really means to JavaScript that like you haven't even set this variable. In some cases, like JavaScript will just happily tell you that even if you try to use an invalid variable name, it'll just say, well, that's equal to undefined, because undefined really just means that it has not been, that name, that variable has not been defined. It does not exist in the current scope. And null is like a more explicit, like this variable has a value, but the value is nothing. This just means it has a value, but the value is nothing. It's kind of like the value being 0, but it's not a number. It's null. It's its own thing. There's no number, there's no string, there's no nothing. It's null. This is why, like, this stuff is largely the reason why you'll see don't use the 2 equals in JavaScript. Use the 3 equals in JavaScript, because JavaScript will try to convert between all this kind of stuff. And sometimes you want to be sure, or most of the time, if you're looking for null, you want to be sure that it's null, that it's not undefined or 0 or anything else like that. So here's what happens if you do the double versus the triple, and you say null equals equals undefined, or null equals 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 undefined. I don't know if anyone wants to try to guess what the first one will be and what the second one will be. But we're going to keep going in a couple seconds, no matter what. Okay. So when you do double equals, and this one is null, and this one is undefined, JavaScript is going to say, yeah, those are pretty much the same. So true, those are equal enough. The triple equals will tell you, no, one is null, one is undefined. That's not the same. And usually you want it to be more strict like this. So that's why, unless you really know that you want to sort of silently consider null to be the same as undefined, or, I mean, even if we did like null and 0, I'm not sure. Will that still, no? So 0 is not double equal to null, but 0 and false they will double equal. It'll say, well, these are close enough. This one is false and this one's false, or empty string and false. It'll say close enough. They're pretty much kind of equal. One is falsy. And usually you don't want that to happen. You don't want to silently convert a string into a Boolean or a null into an undefined. So that's why you want to use that triple equals. Okay. All right, here's our first new type. This one we've only kind of seen indirectly. This is the object type, and this is a very, very powerful kind of type in JavaScript. And it shows up all over the place, and it's very, very useful. But we haven't needed it yet, except, when you say console, I think console is an object. So let's jump over here and let's just check type of console. Oh, whoops. Console.log, type of console. A little weird, but console is something, so we can check what type it is. It's an object. And the dot, you've seen the dot everywhere, all over the place. You've seen math.py, you've seen array, some 3.map, the dot is a operator that only works with objects. And it's like this property accessor. And I'll explain what this means by this example of an object. So here are two objects. This is how you describe them. An object is an expression, or it's basically like, it's the curly braces also, but it's not a block of code. It doesn't go in the place where a block of code goes, an if block or a function block. It goes where an expression goes. So when you're assigning something to X, it goes where you would put, 1 + 1, this expression. Instead of that, you do the curly braces and you use this convention where there's a property. This could be, these can basically be any variable kind of name. So, there's single letters here, but this could be boo if you want. And that's fine as a property also. And once you've defined your object, and you can write them out on multiple lines if you want it to be a little more readable, it's going to have these two properties. An object is sort of like a box, like a container, which contains some number of other things inside of it. And you access those things inside of the object with the dot, with the little dot. And that's where, whenever you see the dot in other places, that's really what's happening, is that the thing is an object and you are accessing something that is sort of, it's inside of it, sort of like this, by using the dot whatever, dot boo or dot a. So in this case, we have X, Z, we're going to do an addition here. We're going to do X dot A, which is going to be this, which has the value 1. And we're going to do Y dot B. Well, there's no B in here at all. So Y dot B, that's actually going to be undefined. So when we log Z, it's going to be, I think, not a number. I'm not sure. Yeah, not a number. But let's say if we make this B, now it's going to be 4 because X dot A, X into the object dot A is 1. And Y dot B is 3. So it's 1 plus 3. And that whole expression now, now that we can evaluate that whole expression to one value, it's the number 4, we assign that to Z and we log it. Yeah, the entire object literal. It's called, so when you talk about a string literal, it's this stuff. That's a string literal. It's literally a string, I guess. I don't know. This here is a number literal. This, all of this right here is what's called an object literal. So it includes the curly braces and everything that's inside it. Thanks, Karen. And it only has the meaning of an object if it's in the place where you would put an expression. So it's fair to put it here. Well, actually, no, it's not fair to put it here because JavaScript assumes that this is not an expression. It assumes it's a block of code, and it says, no, you can't have that. So it really has to be something that you assign, and it goes where like any other expression that you would assign would go. And that's this is a literal object. Now, X is an object. If I do type of X, console.log type of X, it's going to say object. So X is also an object, but X is not a literal object. It is a variable that is an object. So it's a variable that has been assigned an object. But in your code, when you see the actual curly braces, that's what's called a literal object. Or an object literal. Sometimes you hear it described as object literal. Yeah. And oh, thank you. Yes. This and this and this and this, these are called the properties. So when you do X dot whatever, these are properties of an object. That's what the name of those are. Now, there's another thing that you can do, which we won't really get into now, but you could do C, and this could be a function. Return blah. And in this context, when it's a function, it's still a property, but sometimes you call a function that's a property, you call it actually a method. So I think we need like a little cheat sheet with like all these terms. Object is this thing, or an object literal is this thing. A property is this thing. The value of that property is over on this side. This is also a property, but because you can run it, it's also called a method sometimes. And if you wanted to say y.c and run it plus y.b, well, this is the result of running C is going to be the string blah, because it's a function. And then you're going to concatenate, because this is already a string. It's not going to add anything. It's going to concatenate to another number. Very confusing. Blah, exclamation, concatenated to, it's converted your number into a string so that it can concatenate, because yay, JavaScript, it just converts things around. Sorry, that's just a little too much, but all you should take away from this right now, we're going to do more on details about objects. We'll get into methods and all that kind of stuff. But today we're just talking about the properties, the values, and how you show like a literal object. And then the fact that the dot, wherever you see this dot, it means that this thing is an object and you're accessing a property. Now, in this case, log has to be a method because you're running it like a function. But the dot always means access a property on the object to the left. Property name on the right of the dot, object on the left. Okay, so that one is quite that's a splash of cold water probably, because all the other stuff, it's like, well, we've seen this, but object is new. Oh yeah, I had it like, yes, there is no y dot b because it's not one of the properties in your y here. So it has to be y dot c. Okay, here's another thing about objects. We've seen this other convention. I'll just copy this. We've seen this other convention where here's an object just like we saw. So X is an object. The object literal that shows, you know, all the properties and everything is right here. In this case, the property is word, and the value of this property is the string goodnight. We've also seen the square brackets. This is, remember we had the dice, the die face with number 1 here, number 2 here, number 3, and all 6 die faces that were all wrapped in these square brackets. This is called an array. This is just a sequence of things that you can access. But under the hood, in JavaScript land, it really considers an array to just be a kind of object. And there's no 0 here and 1 here, but that's really what JavaScript is understanding the square brackets and the list of things inside it to mean. You don't have to put any property name and colon. It will understand that you are basically saying 0, it's basically like a property, 0 is moon, and 1 property is stars. And it's very strange because, you know, this is always kind of like a sequence of things that counts from 0 to however long your array is. But it really behaves very similarly to an object. So here, this is illustrating something a little tricky. Let's go into the node console and I'll kind of try to explain this rather than just unpack this whole thing all at once. Yeah, square brackets, the literal array here, or an array literal, is what you get when you have this kind of expression that is wrapped in square brackets.
So is it always in order?
The array, yeah, it's always
like it would, like moon,
thing,
like the top thing would always be the 0, and then the next thing would be...
Yeah, exactly. The first thing is always the 0. The second thing is always 1. There is no 2 in this case because there isn't, or actually 2 is undefined because we're in JavaScript land and it says, well, it's undefined. But yeah, if you put a third thing in here, that's going to be the 2. This is the property 2, basically.
Right. Okay.
So let's try this out a little. I'm just going to go to node so I can type things out and not have to save every time. So I'll paste this into here. Const x is this object. Const y. Now, one thing I didn't mention about objects is if I do x dot word, you can see that I've accessed the property word in the object x. And the value, of course, is what we've set here. Now, this works also for assignment. So I could say x dot other word equals good morning. And now x, if I just look at this whole object, it now has 2 properties. So you can use this dot on the left-hand side of the assignment, the equals operator, to actually put a value into a new property. And in fact, even though this is a const, even though we've said x cannot change, I can overwrite word because word is inside x. And the only thing that's constant about x is basically the curly braces wrapping and this is called the reference to the object. We'll talk about references now, in a little later. But I can, even though the x is constant, the object itself is constant, and you can't say x equals something else. I can say x dot word is now something else. And that's tricky. So now x has changed, but if I try to do x equals a is property is 1, like a brand new object, that is going to say no, x is constant, except I just changed something inside of x. So constant doesn't always mean it will always be the same thing. When your variable is an object or an array, it's like all bets are off. So that is definitely something tricky to watch out for. That will get you. You will be probably surprised by a bug that's caused by you assumed that something was constant because you used the const keyword, but it was an object, and you can still go in and modify the properties on that object. Okay, so enough of that though. We have our X object, we have our Y array, but we can do the normal way of accessing the first item in Y. And we saw this a little, you use the square brackets, sort of like you use parentheses to call a function, you use the square brackets to index an array by convention. So if I did Y, the index 0 item in Y, that's what this means. The 0th in the item at the 0th index, and that means the first item. It's going to be moon. I can also do y dot 0. Oh no, I can't. Never mind. Never mind. I can do it the other way. Sorry. I can do it the other way. Yeah, okay. Ah, man. My JavaScript is a little rusty. You can't do anything dot a number. I could do y dot anything else though, I think. Yeah, and now y, it looks like an array. It has square brackets, and this is 0, and this is 1, and this is ASDF. So if you accidentally assign something to a property on your array, you're going to end up with a very weird value, which, yeah, so that's confusing. And obviously it's confusing enough where I don't really remember all the rules, as you just saw. So yeah, something to watch out for. Arrays really kind of are objects, but kind of not, because somehow it does know that this is mostly an array. It's mostly an array. Yeah. So X, this works the other way though. I can do X and then use the same square bracket thing, and word here is the property I want. So in this context, I need to pass this, I need to say the index of this really is a string. And if I go like that, I can access it the same as I can do X dot word. Those are the same. But the array, oh, and I guess I can't do X dot 0 equals anything either. Yeah, it doesn't like the number there. So in order to access something with a number, I could do X bracket 0 equals something. In order to access a property that's a number, you need to use this square bracket thing. Now X has the string 0 key is ASDF. The string word key is also that, and other word is good morning. And I still can't do X dot 0 because the syntax, it doesn't like the 0 number right after the dot. It can't figure that out. So I still would have to do X0 like this. But it's very odd that it thinks this is a string, this is a number. It's fine looking up this here. There are just very many little quirks about this. Generally, I would just recommend, you know, a lot of this is just warning that like you could see some weird stuff. I wouldn't worry too much about. You're not in practice. You're never going to want to start assigning a zero property on an object. That's probably a terrible, terrible idea. So it's just a warn. It's just a heads up that there's some strange behaviors, and that arrays kind of are like objects, and objects kind of are like arrays. But in most cases, you're going to want. I'm going to quit and then start node again. In most cases, you're going to want to keep it so that, you know, y has just number keys. Y 2 equals sun. You're going to want to only use number keys with arrays. And you're going to only want to use string keys with objects. And you can do the dot for convenience, or you can always use this string thing with the same brackets that the array has. And that's because they're a very similar structure. Usually the convention is, if you can use the dot with objects, pretty much always use the bracket with arrays, because you can't access a number with the dot. The only time you're going to want to use the bracket with an object is if somehow you said, well, word is like another variable somewhere. Const property name is word. And sometimes you want this to be able to be one of several things, and this to be controlled by the program. And then based on the, you know, the value of this should correspond to the property that you want to get from this. So in this case, you could say x square bracket property name. Oh, whoops. Const, I haven't defined it down here. Const property name equals word. And then I can do x index property name. And that's good night, because word is a string. I'm using this as to index to x. X has this property with the key is word, and it matches this. So this is a kind of a more advanced thing, which you might not use very much at first. This can let you control which thing you pull out of an object with the value of another variable. It's a little tricky. In general, though, you're going to want to use the dot for objects. And you're going to want to use the brackets for arrays. Well, this one's undefined because we only have 3 items. So the index 3 is the 4th item, and it's undefined. Okay. Why don't we do a little pause? Just let's take some questions. I think, like, you know, a valid question is, how am I ever going to remember all of this? That's probably what some of you or most of you are feeling right now. That's okay. This is the first time you've seen a lot of this. You're going to, you know, need to stick with it for a while and get used to them. And oh, push, Brandy. Yeah, we can talk about that. Let's see. Yeah, this stuff. Okay. Push is a method or a property that's on every single array. So y.push, if I just say, what is y.push, right? Well, y has a 3, y has a 2, y has a 1. Y also has a push, because it really is an object. And if I look at this, what is push? It's a function. So I can run it. I can say y.push 4. And that adds whatever I pass to the function onto the end of the array. And there's actually many other functions or methods or properties that you can run like functions that are on arrays. Y.pop is another one. So if I do y.pop, this takes the last thing off of the end of the array. So now y only doesn't have the 4 anymore. And this method actually returns the 4. So this is a nice way to say, hey, remove the last item off the end of the array and give it to me because I want to use it. So I could say const, const my thing equals y.pop. And then my thing will have stored, any guesses?
One, two, three.
Yep. And y, as a side effect of running this, y only has 2 things now because it's been removed and becomes the value of this expression basically, and then that is assigned to your variable. So the variable gets the thing that's popped off the end, and now that it's been popped off the end, the array is smaller. And you can actually do this with the other end of the array too. You can say y.shift 1. And oh, whoops. Shift pops off the front side of the array. So shift will grab the first item, not the last item. Pop grabs the last item, shift grabs the first item. And now y only has 1 item. Now to add to the first, to the beginning of the array, you can do y.unshift. And that will add onto the beginning. And this, for some reason, returns the new length of the array. I guess, does push do that too? Yeah, push returns the new length of the array too. So now unshift, I've stuck it on the front. And again, push sticks it on the end. So I pushed 5 is here. I've unshift 1, that's here. So those are 4 different methods that all kind of have corresponding behavior. It's for sticking things on either end and popping things off of either end. And then arrays have other methods. You can actually look up, array methods, MDN. And all the methods are going to be described here as, let's see, array.prototype.whatever. So we've seen, let's see, we've seen pop and push. We've seen shift. We've seen unshift. There's also splice, sort, sum, reverse, reduce, all kinds of fancy stuff. Map, we saw map the other day. Map is a very interesting one. We'll talk about functions in a bit, but you can say y.map and pass this function another function and say blah plus x. And this is going to say blah 1, blah stars, blah 5. It's a new array that has every element of this old array has been mapped using my mapping function to a new array. This is some next level stuff. This is once we get it, when we're going to get into functions very soon. Actually, that's next. But yeah, I think it's probably too early to take a break. Let's take a break at 7, but let's start to poke at some functions first. Okay. Okay, symbols are weird. You're not going to see them everywhere. I'm just going to skip this. It's just another kind of type officially, and I wanted to be exhaustive and list this, but symbol is like unique thing. It's just, there can only be one symbol that has the text ABC. And this is just a unique value. It's kind of odd. You probably won't see them anywhere. Okay, and functions. We looked at functions a little yesterday, and we're going to look at them more today. This is how you define a function. And in this case, the function takes one argument, x, and it gives you back an expression, which is whatever happens when you do x, the plus operator, and 1. So if you call increment and you pass it the number 5, it's going to return 5 plus 1, and z will be assigned 6. So you'll see it log 6. And if you don't believe me, I will quit node and run it to prove it. There's 6. So this is basically, we've seen, calling functions and defining functions here. Yeah, and then we're going to talk about these different methods, but there are 3 different kinds of ways to make a function. You can define it like this, where you just start your statement with function, and you have a name, the block here, and the return inside. You can assign a function. You can just have a function expression, it's called. This is just another kind of expression, and then assign that expression to a variable, just like with a const, like anything else. And that will also make a function called increment. And then finally, you can also assign one of these things, which is the same idea basically, but this is called an arrow function. It's a shorter way of doing it. This is what I was doing when I did the map here. It's just a shortcut way to basically have a literal function and a function expression. It's this value gets assigned to this variable just like any other. Same thing here. This value this is a function. It gets assigned to a variable. Yeah, if they're never assigned to anything, they're called anonymous because they're never given a name. So when I did the map, it's never given a name. This is technically, it's an anonymous function, which literally means it has no name. This is some fancy stuff. I don't know if I want to get into this, but you can take a function expression and you can invoke it right away. And then the entire result of all of that is itself an expression. This gets tricky. But like if you say, I will make a function expression, wrap it in some parentheses, immediately invoke it, call it right away, pass it the argument 5, the entire value of this expression is going to be what it returns. So in this case, if I copy this console.log, this whole thing, another parentheses, this is very confusing. It's still going to log 6 because of all this stuff. Very confusing. I don't expect anybody to really understand this for quite a while, so don't worry about it. If you do want to ask questions about it and try to understand it, I would be so happy though. Like, come to office hours, ask about it. That would be so much fun. Try to, it's going to be hard, but yeah. Okay. Functions we've already looked at. This is just kind of like digging a little deeper into functions. So this is the one we did the other day. We had the say hello function. You pass it a string as its argument. String becomes bound to this thing called name. And you can log a bunch of other stuff and put name in the middle by concatenating. We also had this alternative where we use the backticks and the interpolating thing. Same idea though. The only difference is instead of logging it inside the function, we have it return what it would have logged. And then it's our job outside to log it. And the difference is this one doesn't cause anything outside, any side effects. This doesn't assign any variables. This doesn't cause any output to the screen. It only takes an argument in and returns a value back. So it's a pure function. It doesn't have side effects. And that's unrelated, by the way, to the backticks. That's just also a difference. It's another difference. This is the second way where your function is itself an expression, and it's assigned to a variable, just like a const variable, just like anything else. So this could be 1, but no, it's a function. And it works just the same as the last way. And then this is the third way. It's also a function. It's also an expression. It can be assigned just like any other expression. But this one uses the shortcut. This little arrow here means that it's a function. There is one difference, and that is about the scoping of the variables inside the function between, this arrow thing and using the word function. The only significant difference is that variables are scoped a little differently. Actually, there's two differences. Let's not get into them. We'll do this next week. But this, for the most part, you can just think of it as a shortcut to avoid typing the word function. Now this is the shortcut method still. This should have a semicolon, I guess. This is still the shortcut method. It's using the little arrow. It's an equals and a greater than sign together makes this little arrow. It's the shortcut method, but now we have two arguments. So you have to wrap them in a parentheses and separate them with a comma because you have two arguments. If you have one argument, you can just go like that and it sort of just figures it out. But any more than one argument, you need these parentheses and you need this. And these here are optional. If you remember the last one, there's no curly braces at all. And there's just an expression here. And this is the shortest, it's just more shortcut stuff. This basically lets you say, I don't want to make a bunch of statements. I just want to return something immediately from my function. And it says, okay, well, in that case, you don't even need the word return. You don't need the word function. You don't need the word return, because if this is just an expression, it's going to understand that, oh, you must want to return this expression. If you put the curly braces in, you also then need the return, because it's like, well, I'm going to treat this like a normal function with normal statements inside of it. And if you want to return anything from it, you better have a return statement. So that's why this is here, is because these are here. Okay, as you might have noticed, functions are very complicated. They're very special in JavaScript. They are much more complicated or sophisticated than they are in a lot of languages that came before. Python and C, the functions in those languages are pretty clunky by comparison. They can't do a whole lot really easily. You have to kind of like use all kinds of weird tricks. In JavaScript, functions can do all kinds of strange stuff. They can be passed into other functions. We see this with the map function, .map, and then you pass inside a function. So a function can be passed to a function. A function can be returned from a function. They're basically just like any other value in JavaScript. They're what's called first class. So JavaScript, you say it has first class functions. This means that function values are just as usable as all the other values. And this leads to some very tricky techniques, which are very useful, very, very useful, but they're going to be very hard to understand for a while. And that's totally fine. That's totally normal. Everybody smacks into this like function, like what's the deal with these function arguments, the map thing, this thing. It's going to be confusing for a while. So, you know, like you have my support and my sympathy and just, you know, you're going to have to stick with it for a while. They will slowly start to make more sense. Karen, is that true? Do function arguments make sense to you like a couple years in? Uh-oh.
Yeah, it takes a while. Probably when I was first doing it, I was like, oh, okay. But then, like, once I got out of the program and I wasn't doing it every single day, and, you know, and then went back into it after like a month or so, I was like, oh, okay, go back and rewatch everything that you did so that you can, you know, it takes a while. You're not going to know it
Right away.
Don't expect to memorize it all either. Like I still reference books today, but you'll get there.
Yep. It's a function of consistency and time.
Practice.
Practice. Yep. Okay. So here's like, you know, there's a lot of repetition in this, and this is for a reason. It's because it's going to take a lot of seeing this stuff over and over again for it to really start to make sense. We're only going to get so far today. If you're sick of this at any time, by the way, just say, all right, enough functions. Let's do something else. But I'll try to, you know, show this in one more way. Here's an example of a very basic way you can pass a function as an argument to another function. Now, we saw that arrays all have this property called map. And in fact, you can do this right away. Like you can do a literal array and then immediately use the property that's on every array, .map, and run this. And this is a method but it's a function. And the argument to map is itself a function. So if we define something here called multiply by 2, this is a function that takes a number, returns that number multiplied by 2. Pretty simple. This function now can be an argument for map. And let's try running this. Who wants to guess if we console log this? What is this going to print? We take the array that has 1, 2, and 3 in it, and we're going to call the map function that's on that array. And the argument we pass it is our multiply by 2 function, which takes the number in and returns the number multiplied by 2. Now, if you can guess what this is going to return, you're more ahead than I thought. Let's see if anyone can guess this. Oh, Melikwan. Boom. How'd you figure that out? Did you Google that? All right. Nice. It returns 246. Exactly. So yes. So what it does is it takes this function as an argument, map. What map does. It takes this function as an argument. It goes to each item in the array. It runs this function. It passes that item into the function that you provided here, and it takes the return value of that and pushes it into a new array, and then it gives you back that new array. So it's a way to transform everything that's inside an array all at once by some rule that you define by specifying it in a function. And this is like a very basic way that passing functions to other functions can be a very powerful technique. Because in order to do this normally, you would have to do a for loop. You'd have to say, let my new array is an empty array. And then, you know, here's my old array. Or I guess they can both be consts because we're just pushing and popping or pushing to it. Carolyn, you're hearing like a record crackle?
No, it's like a.
Does anyone else hear like a
I don't know if it's
whooshy?
on your end or someone else that's unmuted, but it started a few minutes ago and it sounds weird and
Okay.
it's annoying.
Let's see, is anyone?
I don't hear it on my end.
Records for your jazz.
Okay. I don't see anyone else unmuted. It's either me or it's your computer. I don't know. Sorry. I mean, we can try restarting, but if it's not too much of a problem, we'll just, yeah, okay.
I think it might be on your end, Carolyn, because I don't hear anything coming from Gus's end.
Okay. I'll try to talk over it. So, if you didn't have this map technique and this fancy way of passing a function to a function, the only way you'd be able to do the same kind of thing would be like this, like for let I equal 0, I is less than my old array dot length. By the way, every array has a property called length also, the dot length. And that will give you the actual length of it. And the less than is because, remember, all the indexes start at 0. So you have to be less than the actual total length to have a valid index. An array that's 3 long, the last index is 2. Tricky, tricky. So you'd have to do this like a for loop, and then you'd say my new array I equals my old array I times 2. And this works the same. I mean, this would do the same thing, but this is a whole lot more code than this. And this actually can be further shortcut. You don't need to define it up here at all. You can do this. That's the shortest way to do it. So this does all of what this would do, but it's so much shorter. 246 in both cases. Okay. So this is that second method, the one I just did. The anonymous function expression here. It has no name. It has not been assigned to anything. And it's basically a expression. The value of this expression is a function. And then you can pass this expression as the argument into this function. So function passed into function. You could do it just as well without the arrow too. You know, this is another function. It's an expression. It's anonymous. It hasn't been assigned to anything, but it's a function being passed into a function. When we get to like callbacks and things like that, you're going to see this kind of thing a lot, where you say, where you pass like a callback function into something, and that's a function you should run once your API call finishes. This comes up a lot in asynchronous programming, which we're not going to get anywhere near for, I think we're not going to do it until you're with Max, probably. But, you know, you're going to be passing in functions as arguments in order to do asynchronous styles of programming, which is like loading things from servers, waiting while you do this and doing something else, and then going back to it, that kind of thing. Okay, here's the other half of that. Functions can return other functions. So this is a way you could basically run a function called add factory. You give it this value. Inside this function, you declare, oh, no semicolon there. This is the, you know, there's no semicolon in this way and there is in the other, and it's sort of just confusing. So whatever. You can skip them often, it'll still work. Anyway, inside this function, you declare a brand new function, which uses the thing you passed into the original function right here. but it also is a function. It's not, it doesn't run right away. It's just a value, which is a function. And you return that function from this function. This is probably a little less common. You don't do this kind of thing as often in most normal kind of like programming patterns, I think. If I can remember a really common use of this, I'll let you know. But here's the short version of that. You can say, here's your value passed into the factory, and you return this shorthand function, which takes the x and returns x plus this thing, which you passed into the outer function. So if we do this, I can say const my adder equals add factory 5. Const my other adder, or actually we'll call this add 5. And this we make by saying add factory, passing it a 5. It becomes this value. It becomes bound here in this function. And this is what's returned, this new function, which is called add 5. And another one, add 6. Add factory 6. Same kind of thing. This becomes this becomes here, and it's returning a new function that effectively adds 6 to whatever you pass it. So now if I say console.log add 5 to 5, it's going to be 10. And if I do console.log add 6 to 5, it's going to be 11. So maybe this one is even more confusing, and it's probably less common, but if you have some need to like make slight variations on a function based on, some parameters here, this is also sometimes, this kind of pattern in general is sometimes called like partial application. It's really not the same exact thing. There is a special way to do partial application of functions where you kind of give it some of the parameters and then fill in the rest later. This is kind of a weird way of achieving that same thing. But it's not as common to see this exact pattern. Okay. Okay. I think let's take a little break, decompress a little bit, take some breaths. If there's any other questions, I'll be around, but let's take like 10 minutes and come back at 7:15, 12, 13 minutes. That sounds good. 7:15, let's start up again. We'll talk about the values versus reference types. This is why objects can still be modified even though they're const. It's because of value and reference types. We'll talk about that a little. If we got some time, if everybody's got the energy for it, we can talk about scope a little bit in detail. And then let's just keep it open-ended for the rest of today. We can do some tinkering in the browser. We can try browser JavaScript if you want, if you're sick of Node, or whatever. Let's just talk about that later. So I'll see you back here at 7:15.
Excuse me, Gus.
Yeah.
It's Latonia. I actually have a couple random questions. Can I just send them to you in the chat? And if you feel like answering them, you can. Or I can actually send them to you on Slack. You can determine if you want to answer them with the whole class or not. They're kind of like work specific, and there's no rush on them.
Yeah, sounds good.
Okay.
Anytime, literally anytime on Slack. If you don't like, if I'm not there at the time, I'll respond, as soon as possible, and it can be asynchronous, or
yeah, sure.
During the day at work, I have it open all the time, so I'll usually be able to reply if I'm not in a meeting or whatever.
Yeah. Okay. Did you all pick JavaScript because you and Karen, did you both pick JavaScript because it's like one of your favorite topics in code? Like, how did you both end up?
You mean teaching this module?
Yeah.
I don't know. I think like, yeah, I guess like and I don't know. I think this is one of the trickier modules to teach, and I'm kind of interested in the difficulty. I hope I'm, doing an all right job. I don't know. There's no way to really make this easy.
Yeah.
But I sure am trying.
Yeah,
This-
I think you are. It just feels dense. Like it's not you. We literally don't know what to ask you because we don't know.
Yeah.
It gets better, I promise. I swear. The first week of JavaScript is
This is
always
like-
the hardest.
Okay.
Yeah, and I think last cohort when I was teaching, I think I taught the same week, and it was harder. And I think one of the mistakes I made was not like do that pause at the beginning and be like, everyone get ready. We gotta get mentally
Yeah, well,
focused and ready.
But that was learning curve for everybody. Like we didn't know what we were walking into, and this was the first time you guys were all doing it. And but it does get better.
Okay.
Everything that he's teaching you as it goes on, it will all tie in. So like next week it'll tie in, and you'll be like, oh, okay. And
you're gonna be seeing this stuff over and over and over, and you're not gonna be saying, aha, that is a method, which is a property accessor, which is a blah, blah, blah. You're never going to be thinking exactly those words,
Right.
but you're going to see these things over and over again, and they're going to just become more and more comfortable gradually. Yeah.
Okay.
right, and you'll know how they work.
And there's not a whole lot of new stuff that is, this difficult to wrap your head around, I guess. There's a lot of new stuff.
Uh-huh.
But I think it might be fair to say that like the kind of like newness of some of the stuff this week is the most just newness. I don't know, because a lot of the stuff when we talk about React, it looks kind of familiar, and it's just going to be reusing the same JavaScript pieces you'll already be used to by then.
Yeah.
So
yeah, I think it really helped the way you all structured the program, because we did get some stuff from Karen when we were working in the console and stuff before. And then like I found like when I was reading the reading material that you gave us, like it makes sense. Whereas if I had read it in advance, I'd be like completely clueless. But I guess that could work either way. You know what I mean? Like the reading is helping me to understand some of it, or at least feel like I understand it.
Well, every time there has to be some repetition, and there's I'm revisiting things from, and you will continually see a lot of the things more, and it's a little bit of a waste of time kind of, because you're covering the same thing again, but it's really worth it. It's really necessary a lot in a sense, because repetition is really important for like learning some of these gnarly things which are really tough to get your head around, Yeah.
Repetition always helps me. So.
Yeah.
Cool. So I hit you with 3 quick questions. Like I said, there's no rush on them or anything. Just whenever you get a chance.
In Slack or in?
Yep, in Slack. Yep, I DM'd you.
I don't see it.
Oh, sent it. Slack is really funny. Like it won't tell me I have messages, but I'll get an email saying I have messages, and it's like all over the place. But it says I sent it at 7:09, and I did at you, so I don't know why it's doing that. I would say give it a little bit. Maybe it'll kick through.
Yeah, maybe they'll pop up, but I guess try again. Yeah, you can always just attach them to one of the homeworks and say, hey, here's the question. But
I know. I feel like I asked many
as
questions as it is, but
yeah.
Alrighty.
Ask the questions. That's how you'll learn.
I know.
Don't feel bad about asking them. Ask them, because you might have a question that somebody else also wants to ask and doesn't.
Yeah.
Yep. In class, out of class. I mean, please, nobody have this misconception that like any of us or any of the teachers or TAs are like, oh no, I got to answer a question. We're so happy when somebody is thinking and trying and engaged and really wants to understand something. It makes me so happy. So like, please ask questions. Please ask for help. It's the whole point of what we're trying to do. So like, don't feel bad about it. Definitely.
Okay. Well, I may be kicking it up a notch because like I'm just like cross-eyed after I read some of this stuff. But
yeah, that's not surprised. That's that's how it is. Yeah. Yep.
Yeah, sorry, not to interrupt. You lost me after map.
Okay.
Like, and I mean, I've taken JavaScript. I'm lost. So I'm not sure if that's something we'll go back over
Oh,
at some
definitely.
point.
And come to office hours and
No,
and
yeah.
like I am not surprised. Like the pace of this boot camp is intense, and it totally makes sense that like a little more than halfway through class, you're at the limit of new things you can stuff into your head in one day. I mean, I would be. It's if you're if like it is, and I think I need to start, or like one of the things I'm really kind of getting a better sense of is like I need to start kind of like only putting like basically half of the class time worth of new stuff in any one day, because it's a lot of it starts just bouncing off of people. And I can, by the way, you can see that sometimes on the camera if people are sitting there. The beginning of class, everybody's like kind of smile, like, ooh, interesting. And then by the end of class, it's like a different face. It's like that.
And I apologize because I really don't feel good. So you stopped at one point and I went, oh God, if he looks at the camera, I look like I'm so zoned out. No, I have
No,
notes.
no,
You lost me after map when I think it
yeah,
was
that's
Mel
not
got that
that's
2,
not
4, 6. I was trying to arrange the arrays by 0, 1, 2. I don't know what happened. Yeah.
So the numbers in that case are totally independent from the indexes. And that's not necessarily the best example. We should do like 5, 6, 7 maybe, or something. They're totally different. 0, 1, 2, 1, 2, 3 is just a coincidence, in that example. Yeah.
Okay,
And don't
thank you.
apologize because like again, not surprising. This is like if you were saying, oh, I got everything, I figured it all out, I would be like, what? That's ridiculous. I would be like, that's crazy. So yeah. I don't know, some people might be getting this quicker, but I bet a lot of those people probably have also had maybe not exposure to this exact thing in JavaScript, but enough kind of familiarity with the general ideas, perhaps. And that familiarity is really what we need to build by spending time on it and by kind of repeating. Yeah. But yeah, this is some of the hardest material for sure. It's definitely going to get easier. Not that much easier. It's going to keep, we need to keep at it for, many more weeks. Yeah. So I don't know. I think maybe we can vote on like, should we push forward into, we should do this value versus reference a little bit, just to clarify that. But maybe leave the scope stuff for next week, because it's too much, I think, for one day. So yeah. Okay, it's I think we can start up again. Hopefully everyone's back. Turn down the music. Yep. Algebra and statistics, they are both I mean, I use them both in my job. Now I work at a tech company, so it's very like techie programming. A lot of programming is just basic like business processes. Turn this process into code. Like it's not as mathy as some of the stuff I'm doing. But yeah, algebra, the kind of thinking you do in algebra, it's similar in a lot of ways to sometimes the kind of thinking you do with programs. And it's a very different approach to it. So like I never really liked the math class approach to a lot of things, but you're thinking in the same kinds of ways. You're just using different tools. You're using, all of these, code tools instead of, pencil and paper or Statistics is everywhere in life. That's true. Yep. One thing I barely ever use in my programming in my job is calculus. That's like calculus is only for a couple things. It's like for physics and a couple other things. I don't really use calculus that much. Maybe intuitive reasoning about it, but yeah, there's not much of that. There's not much like geometry. There definitely is some aspect of it that's like algebra. Yeah. Yeah. Variables. Yeah. Thinking about, how to transform and solve for different cases. Yeah, definitely.
Yeah, I I actually read something today, and the guy, and I've heard a lot of other people say this too, is to break it down into smaller parts. What you're doing, and to start thinking like a problem solver basically. And he gave a couple of like exercises, his examples, and one was the farmer exercise. And it just said, there's a man on the bank of a river. He has a boat, a bag of grain, a chicken, and a fox. The man needs to get himself, the grain, the chicken, and the fox to the other side. The problem is that he only has enough room for himself and one of the other items on the boat. And the boat cannot row itself, of course. The fox wants to eat the chicken wants to eat the grain. What order does the man have to transport the items across the river to ensure that all items remain safe?
Yeah, I've heard this one before, so I won't spoil it, but we can write that down. That's a fun puzzle. It's not that complicated, but there are like lots of steps to it. Yeah. Yeah.
Yeah, he had a couple others in there that I had not seen before, so it was interesting. Did you ever hear the men in the hats exercise?
Maybe, I don't know.
That one is, there's 3 men lined up, and the tallest man.
Yeah, I've heard this one. Yeah.
Yep.
Yeah, that's a brain bender. That one is, yeah. We should write these down for like in
Wait,
case you want.
I actually heard that one too, but I read an article. This is the way that I heard about it. They actually wrote an article for Google, and Google said that they asked that in their interviews and as a way of getting to know people. So it was pretty interesting. That one's it was a brain teaser.
Yeah. Yeah, that's a difficult one. There's one I remember that was basically impossible. That's like one of the hardest, and like it's like something about there's like guards at different doorways, and one of the doorways is the right doorways, but you have to figure out which doorway, and you can ask the guards like one question each or just one question, but one of the guards always tells the truth, one of the guards always tells a lie. And then in some of the variations of this, the third guard always gives you a random answer. And you have to like figure out by asking the guards what you don't know which guard is which, and you don't know which doorway is the right doorway. And like somehow you can figure it out. And I totally forget that one. It's like so hard. There's no way like anybody can figure that one out. But there's like an actual solution to it, or it's something like that. Yeah.
The only other 2 that he had on here were the apples and oranges crates. So there's 3 crates. One is just all apples, one is all oranges, and the other one is apples and oranges mixed, but the labels are all wrong. So how do you pick just one fruit from one crate to figure out what's in each crate?
You lost me, sorry.
Yeah, there's 3 crates. One has oranges, one has apples, and one is a mixture of apples and oranges.
Oh.
But the label maker broke, so they're labeled incorrectly. The crates are labeled incorrectly.
You pick one from each crate and you figure out which crate is which.
It says, how could you pick just one fruit from one crate to figure out what's in each crate?
Shake the crate before you pick. I like that. Apples are heavier, right? Or something.
Yeah.
Man, all right. I don't know. This is too much. This is too much. This is like if you want to work out your brain a little bit, and that's a good idea, by the way, because it's just mental strength. It's like just working out any muscle. But we're already doing that today. We're already, I mean, come on, we're already getting some exercise here today. I don't think we need to solve a bunch of brain teasers too. But that's my way of justifying I can't figure it out. So I'm just going to pretend like, let's not even bother. Yeah. All right. Okay, let's talk about one more topic today, and then let's sort of just open it up. Let's have some fun with JavaScript, try some browser stuff, or whatever questions you have, if that sounds good. All right. Share screen. Okay. Okay, so this topic today, I think will be the last one. And it is value types versus reference types. We saw this a little earlier today. When you make an object and you assign that to a variable, objects in JavaScript and arrays in JavaScript, because they're similar, they're basically objects. These are what's called reference types. And what that means is if you assign the number 2 to a variable, just a number, then the bits that represent that number 2 are directly linked to the name that you're assigning it. The same with a string. If you assign the string red to a variable, the bits that make up the characters and make up that string are directly linked to the name that you're assigning it to. An object is different because when you make you have an object literal here, it's an expression, it's a object. This is an object, and you assign this to a variable. The thing you're assigning to that variable is just an indirect locator, a way to find those bits where the object's properties and everything, where the data for the values for the 1 here and the 2 here, where all of those bits actually live. The thing you're assigning is not the bits themselves that make up the 1 and the 2. The thing you're assigning is a locator, a reference, it's called. It's like a card in a card catalog in a library. It's not the book itself. It's a way to find the data you're looking for. And that's why even though you have declared your variable as const and assigned your object to that variable, you can still change the properties in there, because those properties are, when you change the properties, you're not changing how to find that data, you're changing that data. And the only thing that's const, once you've assigned it to constant, is that reference, is the way to find it. And this has some weird effects. Not only can you change the properties inside a const object, you could copy an object and then end up changing the original object because you're finding the same data and you're changing that data. So let me just need to, there we go. I just need to keep this not full screen. So that's what's going on here. We are making we have an object we're describing here. It has 2 properties, A and B. And we're assigning that to a const variable called original. Now you can't do original equals another object. That's not going to work, because it says, well, you can't put a new, assign something new to this variable. But again, remember, when it's an object, the thing we have assigned is just that card catalog card. It's just the way to get to the data. It's not the data itself. So even though I can't assign a whole new object, I could still do original.a equals 5, and that works fine. And I can still do original.b equals 6, and I can even make a brand new property on this object. And that's fine too. So, oh, yeah, let's comment this out for now. So I can still modify this, the data that this refers to, because the only thing that's const is, again, the way to locate that data. And this is different than, numbers, strings, Booleans. Those are called value types. An object and an array, those are reference types, and that's what that means. The other thing about it is, if I can get rid of this for now, if I make a new variable and I assign it the value of the original variable, again, what I'm assigning is not the data itself. It is the way to find that data. And in this case, a weird effect that this has is if I go to change a property on the copy, I've located the same data in both cases. This is a way to locate the data, which is the same as this is data, because it's the same location for that data. So if I modify the A on the copy, you'll see that the original one has also changed. See, I'm setting copy.a to 2, but because this is just a reference and the data it's referring to is in the same place as the original data, then changing this copy's property will change the original's property. And I can do original.b equals 4, and it works both ways. So if I do original.b is 4 and I log the copy, it works, it does the same thing. So the first time I've changed A to 2 and it's echoed on the original because it's pointing to the same place. And the second time I'm changing B on the original and it's echoed on the copy because they both point to the same place. So that the takeaway from this is just that don't trust that you can't modify data just because it's const if it's an object. And watch out for if you do this kind of pattern where you make a copy of an object, you're not really copying everything in that object. You are just copying the reference to the same data as that object. And changing either one will change that same data. Same thing happens with an array. So we can do a similar example, basically the exact same pattern. You make an original, you put some stuff into it. If you make a copy of the original, this is also a reference. So if I change the first item to 2, then I log the original, it's going to say 223, even though I've only changed the copy.
Karen wants to know, Carolyn wants to know, kind of like an alias.
Yeah, it's like an alias. I like to think of it like a locator or like a card catalog, like the data that's really, really stored in this variable. The actual bits that are in this variable are just a location to find some other bits which are stored elsewhere and really have no variables directly pointing to them because it's an object, and that's just how objects work. They're stored in the heap, it's called, in a computer. The computer has a stack and a heap, and conventionally references are stored on the data for references are stored on the heap. A little bit of trivia. You don't really need to know what that means. JavaScript might store everything on the heap. Who knows? It's a very high level language. Yeah. So same thing happens with arrays. And by the way, if I do copy.push 5, well, that's also going to be pushed to the original. And the same with all those other methods. So pretty straightforward to see the consequences. It's a little hard to understand exactly why, but you know, the takeaway is that watch out for objects and arrays. They're not, it's not as simple as just saying, well, I make something equal to my original object and I'm going to have my own copy of 1, 2, and 3. That's not how it works. You only have your copy to the thing that stores this. Now, there are techniques for, watch out with the inner parts of objects and arrays. Consts won't stop anything you from changing them. A shallow copy of an object copies its own keys. But here's the thing that I never even mentioned yet. The values in an object, this one's a number, this one's a number. The values of the properties in an object can be another object. So it gets even gnarlier here. We could say this original has a, which the value of a is 1, a number value. The value of b is the number 2. Well, the value of c could be another object that has d, which is 4, and e, which is 5. So the value of c is another object, which means it's another reference, which means even if I copied each thing out of the original into a new thing, a new copy that has A, B, and C, and I said, okay, get original dot like this, I'll show you. Even if I said const copy equals an empty object, and then I really exhaustively copied copy.a equals original.a. You'd think, well, this here is going to copy that value. The a here really is a value. It's the data that has that number. It's just a number. Copy.b equals original.b. And if I do copy.a equals 10, and then I log the original, the original.a will not change in this case because what I've copied is not the reference, it is the number itself. The a is a number. It's a value type. And by changing this now, the copies A and B are completely different data from the originals A and B. So if I log original, it hasn't changed. A hasn't changed on the original. Now if I do copy.c equals original.c, and then I do copy.c.d equals 10, then all bets are off because we've only copied the C down to the level of C, and C is an object itself. So it's a reference itself. So when I locate the property C and then go to the property D, that's the same data as the original again. So you're out of luck again. Now the original has changed when I change the copy. Yeah. Sorry to spring that on you, but objects can be nested inside other objects, and it causes some weird stuff. If you talk about making a deep copy of an object, that means it will take every single value at the very end of that object. If there's an object in here, it will make a copy of D itself, make a copy of E itself. So this would be like this, copy.c equals brand new object, copy.c.d equals original.c.d. copy.c.e equals original.c.e. Now this here is a deep copy. I haven't copied anything over that is an object from the original. So when I modify anything on the copy, it won't affect the original. There's no 10 on the original. So yeah, anytime you assign something that is an object, this is a number, this is a number, this is a number, this is a number. Before, this is an object. So anytime you assign something that's an object, what you're really assigning is just a locator for that data, and the same behavior is possible. So what we did with all of the stuff, that's a deep copy of this object. We've gone all the way to every value type directly, and copied it on its own, so that we're assigning nothing that is an object, not an object, not an object, not an object. These are brand new objects. Oh yeah, so it can be nested like this. Yeah, 3 deep. Hooray! You wanted it more confusing. This has property my lucky number, more lucky things. This is an object. This has properties day of the week, which is a string, other numbers, which is another object. This has property runners up, which is an array, which is basically another object. And then this one is a number, so that's just a value. So you have to go through to everything if you really want to make sure that you have a totally separate object, a totally new object. You would have to go and copy every one of those individually. Now, a way that you can shallow copy with a shortcut is this 3 dots and then the original. This will copy 1 level deep. So it would do the first level, but any inner objects it's not going to get. That's the shallow copy. There are 2 ways to do it. You can assign the properties from the original onto a brand new object, or you can do it like this: brand new object, and then this is called spreading the properties of the original. These are both shallow copies. And then if you have an object that doesn't have any functions in it, or that isn't too surprising, you could just stringify it out to JSON like you were sending it in an API response, and then parse it back into JSON. And that'll go all the way deep as many levels, as long as you only have things like strings, numbers, Booleans, null, as long as you don't have, and nested objects and arrays are fine. As long as you don't have functions in there, this should work to deep copy. But you probably want to find a library that can do deep copies. I think Lodash might do deep copies. This is something you'd go to a library for. If you want to copy big objects, make a totally separate copy, basically ask someone for help with it. That's what I'm saying. Okay, so I think let's cut it off there with new stuff. This is how objects and arrays are different. They have this weird behavior where they do not copy in the same way as everything else. And by the way, surprise, surprise, I'm sorry I didn't remember to mention this before. Objects can be nested inside other objects, and arrays can be nested inside other arrays. That's all totally fine. JavaScript will happily just do it for you. So we could have an array that is made up of more arrays, like this. Okay, I think unless people are all like, I want to hear more confusing things today, let's skip talking about scope until next week. Sound good?
That's probably good. You got like 3 of them that are pretty much done with trying to retain what you've been
Yeah.
teaching.
Yeah, we'll talk about this. We'll talk about this again for sure, at least one more time. So, so this is you know, you're just to get your first exposure to it, and you'll see this plenty more times. It'll start to make sense gradually. Okay, do you want to maybe jump over to what do people what do you want to do? Do you want to ask questions about particular topics? Do you want to just see some interesting code? Do you want to go into the browser? Do you want to just keep JavaScript in the browser? Everyone wants to escape node land and go to the browser. Okay. Let's do that. Cool. Yes, you can watch the videos as much as you want. And absolutely, if you don't want to spend the time trying to scrub to the part of the video where, and then replaying it and hoping that it makes sense, you can absolutely ask a question. We are also real people you can interact with, and it's fine to ask questions. I know I sound like obnoxiously repeating that over and over, but I really, really, really want you to reach out with any questions you have. And it's like it'll be a challenge to try to explain some of these things. Again, though, remember from the first day of class that, you know, consistency is what's going to count. So don't necessarily just try to force your understanding of all of this all at once. It's going to build gradually. And yeah, again, I'm happy to try to explain stuff as long as I have energy in the day. And you might want to do that just as like a sport kind of thing, but don't feel like you have to get it all right away. So yeah, reach out for help, but don't feel like, you know, you're going to be expected to memorize all this or anything. This is just background, and this will help when we get into the next stuff. So cool. All right, let's go in the browser. We got some requests to do that. What should we do in the browser? So we can on any web page, so a brand new tab, we can go to View, Developer, JavaScript Console. And this will be the same kind of thing as the node, if you remember from earlier this week. This is the same as typing node and having the little caret prompt and being able to type expressions or statements into here. And unlike the program, you don't have to console.log these, because the way the REPL, the read, evaluate, print loop, the same thing that the interactive node is like, is working the same way this works. I lost my train of thought. The same way the node REPL works, the browser console works. So it will print back the result of any expression you give it, which is unlike your program when you're running your program. You have to actually log your expression in order to see it. So if I do, you know, just as a reminder, hello plus world. One nice thing that the Chrome does, not only does it syntax color, this is unlike our node in our VS Code terminal. Chrome will immediately color everything different colors. See, the plus is a little different, it's a purple, but it will also optimistically run whatever you're doing kind of as you're typing. As soon as it's valid, it will give you a little preview of what it would be. And you don't actually have to run it to see. But if you hit enter, then it will sort of solidify here and you'll go on to the next line. And this is kind of nice because, you know, I could store let x equals 1, let y equals 2, let z equals 3. And all of these are undefined. The let statement value is undefined, but x now is 1. And I could just type x and see that, or type y, or type z, and it will give me a little preview of what it would be if I evaluated x and hit enter. So it's very similar to the node console, but you're all kind of bored with this, just seeing numbers and text. Let's go to a website and have some fun. So let's go to Twitter. And what's a Twitter account that would be funny to see? We can make any Twitter account look like it's tweeting whatever we want. So what would be a good Twitter account to prank? Maybe Jeff Bezos. Is he a...
What, Andrew Cuomo?
Oh boy, no, that's too...
No, we don't want to touch that
No,
one.
we're going to get our funding cut if we make Cuomo say things. That's not... you can't do that.
Let's see.
Lady
Gaga.
Okay. Comedy Central. Let's do Lady Gaga first. Okay. Okay. Everything's got a picture in it. Okay, here's one with just some text. So we can do Control, click right on here. And this will let us jump right into the Chrome DevTools. So if you Control click, right on top of, whoops. Oh, I guess I'll click on the tweet first, pull it up here. And then if you Control and click on just part of the text somewhere, you can click Inspect here. And this will jump right to the developer tools. And it's actually going to be a HTML looking thing. Now this is actually closer to the document object model. It's not the exact HTML that loaded when the page first loaded. It's the HTML that the browser is displaying right now. And it's kind of a version of that. It's a representation of that. So now on purpose, Twitter kind of obfuscates some of this so that it's harder to interact with their, some of these are a little bit, they're just kind of this thing. And let's see, if I open this, you can see here's the text. So it looks like what we have is 3 spans in a row. This span is the first part of the text before the hashtag. This span is just the hashtag. And then this last span is the rest of the text. Or, yeah, it probably starts here actually. But it's like the rest of the text right after the hashtag. And this containing div looks like this is really the whole tweet. So let's see if we can grab the contents of this. Now, one of the things you could do is double click here, of course. And this is the easiest way. You could say blah, blah, blah. And it changes what's on the page to say blah, blah, blah. I'll put a little space before it. The petition to buy our pop on iTunes, blah, blah, blah. Let's see if we can figure out a way to control this with JavaScript. Actually, this might not have been the easiest example because all of these classes and everything are incredibly convoluted. Like, look at that. Like, let's see. I'm going to, let's see. 910AO. Let's see if this, works. So I'm going to copy this class out of the CSS that's on the div, which is outside all these spans that we've. So I'm going to copy this 910AO class. And it looks like it's the first place on the page where we see it, perhaps. And man, everything's just a jumbled letters. They don't use like their normal Bootstrap stuff. They have a whole processing step probably, which mangles up the names of everything, probably to foil me from doing what I'm trying to do right now. So who knows? Okay. Let's go to
I had no part in the foiling.
Yes. Let's go to the console and let's try to run some code. Now, here's a thing we don't have in Node. You might have used this a little bit. You might have seen document in JavaScript, but document is a variable which is linked intrinsically in the browser to the entire web page that you've loaded. So, and the tools in Chrome are pretty sophisticated. You can actually hover over it, and it doesn't say this is an object, this is a whatever. Chrome is so sophisticated, it's saying this is a part of your document object model here. This is like, and it says, oh, you got some HTML in here too. And this is not normal JavaScript. You're never going to see in a JavaScript program, you know, type of this or whatever this is, and it will print out all of this stuff. What this actually has that's like more standard JavaScript is if you do document.inner, document.inner HTML? No. Document dot, element. Okay, well, anyway, let's try to get one element, and then let's mess with that. So document dot query selector, and this is a function which exists on the document object, which is a very special object in the browser, and I don't really understand how it's printing this fake HTML stuff in here, but it's because this object corresponds to something on the page. It's part of the document object model. It's confusing. But we're going to say query selector, and we're going to put a quote here. And this allows you to use a normal CSS selector, the same kind of stuff that you use to write your CSS rules, to grab the elements on the page that match those same selectors. So in the same way you'd apply a CSS style to an element, you can grab that actual element from JavaScript and then mess with it from JavaScript. So we'll use the same format for these CSS selectors. We grab the class out of our the div we wanted to mess with. We grabbed that first class. And in a CSS selector, a class starts with a dot. So we do dot, and then we can paste this thing, CSS 901OAO. And then close the string, close the function parentheses here. And it gives us something that looks like HTML. Now this is again Chrome doing some tricks. You can explore this just like other HTML. The problem is, it looks like we have selected this blue part. See this don't miss what's happening. It looks like we've actually selected this thing, which has the same class, this stuff right here. So Twitter's being a little tricky. Let's go back to our div here and try to find something else. One thing you could do is copy the whole thing and only select something that matches all of these classes. So I'll copy the entire thing, and I'll go to the console, I'll hit up to get the last thing. And instead of putting just that one class in here, I'll paste everything and then put dots in instead of the spaces for everything, which will make our selector very much more specific. It will only select something that has all of these classes on it. And now, if I hover over this, we got the right thing. Here's our div. And now that we've selected it, we can store it in a variable. So I'll copy this whole thing here. And I'll say const tweet equals that. Semicolon if you want, hit enter. And now I have a nice variable which holds this object which corresponds to this element on the page. This is again part of this document object model. This is how JavaScript kind of can interact with the page. Everything on your page, everything in HTML has a corresponding object somewhere in JavaScript. And we've just grabbed the one that is that tweet div. And now if I do tweet, anytime it'll say, yep, your object is corresponds to this div. And now I can say tweet.inner HTML equals blah, 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 blah. And this will change now. As soon as I run this, the object has a property called inner HTML, and assigning anything to that property will cause a corresponding change on the website. So as soon as I run this, this changes to blah, 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 blah. And in fact, I can do some fancy stuff with this. I can say tweet dot inner HTML equals blah. One blah. Now I can say set interval. This is a JavaScript function, which I'm not sure if this is provided in the Node environment, but it's definitely part of the browser environment. You have this global function in JavaScript called set interval. And this is a function that takes another function as an argument. So I can say function, this is just an anonymous function, an anonymous function expression. Now to do a new line without running this thing, I think we're gonna have to, we'll do that run right after this.
Can you make your screen a little bigger? I mean, zoom in a little bit?
Oh, sorry, thank you. Blah, blah, blah. There, okay. Okay, so we still can see our tweet. It says blah now. We'll do set interval. And the first argument to set interval has to be a function. So we're going to tell it what to run at some point. I think you need to do shift enter to get a new line, yet without running it. I'll do it one more time. I'll close my function body. So function goes from here to here. The second argument to set interval is how often to run the function. So it's in milliseconds, so ms. So we'll say run it every 500 milliseconds, which is twice a second. And inside here, we're going to say tweet.inner HTML plus equals blah. Oh no, space lowercase blah. Whoops. Oh no, I typed the wrong thing and I can't edit it now. I have to basically, I'll copy this whole thing. And it didn't like that I didn't end my blah thing. Okay, so paste. We'll close the string, put a semicolon for good measure, put one down here for good measure. Why not? Doesn't really matter. And when I run this, what do you think is going to happen?
Will it alternate between just blah and blah blah every 2 seconds or whatever interval you just said?
Twice a second.
Twice a
second. It will do something twice a second. Yes, Chaga, it will start adding blahs 2 times a second and just never stop. So now Lady Gaga is tweeting blah, 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 and it will just keep adding and adding and adding. And that's because the plus equals, again, is the same thing as saying tweet.innerHTML equals tweet.innerHTML plus blah. So it's taking the old value of it and it's adding one more blah, and then it's assigning that new string back to the same value, back to the same property on the object. And because it corresponds to the div, that means this will just keep growing and growing, and it will actually never stop. And I'm pretty sure there is no way to stop it unless we grab this thing here, which is the return value of this whole thing. This is now asynchronously running our function, and I can do other things at the same time. A bit of asynchronicity here. How do I stop this? I can't, I can run code, but it's still going to keep running my function over and over. Well, what it returns is a number, and that's can be passed back later to a similar function to stop something. It's called clear interval. And we pass it the number that we got back from the first time we ran it. And as soon as I run this, it's going to stop running our function over and over. So this is a lot of new things. This is a little bit of browser programming, some DOM, document object model programming, some asynchronous programming, all kind of mixed up. But some of the pieces should be easy to understand, or easier to understand, like we're passing this function as an argument to this function. And it's the first argument, by the way. First argument is a function. Second argument is a number, this function. And I think if you hover over it, or if I do set interval, in the console, if you're wondering how stuff works, well, yeah. Okay, never mind. I don't know. Maybe if the text was tiny, you could see. Let's see. Yeah, it doesn't really help that much. Oh, this is just our history. Yeah, never mind. I thought it would explain like what the arguments are supposed to be, but maybe not.
Carolyn wants to know, is clear interval similar to break?
Yes, it's sort of like a corresponding asynchronous version of break. So the difference is that if I do like watch, we'll do this. We'll say tweet dot inner. Let's clear the tweet equals empty, or just one blah. Or let's do what Carolyn said. In the shallow. Is that a Lady Gaga lyric? Okay, so now our HTML is back to here. If we did this with a for loop and with a break, there's going to be a difference that you can see right here. Let's do for, or let's set it back to blah so we can just keep doing our blah example. No, let's just add blahs. Okay, for let I equals 1, I less than 100, I plus plus. Inside here, we'll say tweet.inner HTML equals tweet.inner HTML plus blah. This is the same way of doing what we were doing. The plus equals is a shorter version of this. So if we run this, it's going to add 100 blahs, probably faster than you can even watch them going. It's going to go very fast. Yeah, it goes so fast that you can't even see them added. So let's go back to, we need to find a way to slow this down. And JavaScript doesn't have, as far as I know, I don't know, does it have a synchronous sleep? Let's see, Chrome console synchronous sleep. JavaScript version of sleep. Yeah, JavaScript doesn't really have a synchronous way to wait. So it's going to be hard to illustrate what I'm saying. Let me see if I can explain this. back to one blah. And then we have our for loop. And then we have, let's see, if I equals 50 will break. Now it'll only do it 50 times, but it will still happen lightning fast. It will still happen before we can even really tell. And the difference between what we did and what we're doing with the for loop is, number one, we can control how slowly it runs. But number two, while it's running, we can go do other JavaScript at the same time. So like, yeah. I wonder, can we do like a very slow calculation? Let's see. Slow JavaScript calculation. JavaScript code for making my browser slow down. Okay, here we go. Whoa, cool. A slowdown. Neat. Okay, so this will just cause it to loop a whole lot by doing a bunch of nonsense, by just grabbing dates over and over and over until it gets to the right time. So this is like a trick for slowing your code down so that we can kind of watch it run. So first, let's do that. We got 50 blahs. Let's define our weird slowdown function. And then let's do our loop again, but this time, let's do a synchronous slowdown. So we're gonna say slowdown 0.5. And what's gonna happen here is I will run this and you will see the blahs add slowly. But while they're adding, I won't be able to type anything in at the bottom. I won't be able to run anything else. Huh? Wait a minute.
Is it because you started with 50 blahs, so it is already at its limit?
Huh. That was odd. It just did 50 more blahs, but it kind of just paused until the very end. I think that's probably because, yeah, what's actually happening is this code is running synchronously. So it doesn't even have time to update the browser until it finishes all 50. And for some reason, it gives me this console back. Oh, but yeah, if I type anything, I can't hit enter, nothing. So it's blocking the whole thing. It's not even adding blahs. It doesn't even have time to update the browser because my loop here is called synchronous. This is the difference between synchronous and asynchronous, which we'll get into much later, is that this is occupying all of the browser time. It's basically doing this infinite loop, you know, not infinite, but over and over and over until it's checked that half a second has passed. It's just grabbing new dates over and over, probably millions of times in a half a second, or thousands of times in half a second. And while it's doing all that, it's blocked. I can't even enter any stuff. And then at the very end, finally, the JavaScript has stopped running synchronously. It finally kind of lets go of control of the browser, and all of the updates happen at once on the screen, and all of the stuff I tried to type tries to run all at once on the screen. So that's I mean, hopefully that kind of makes sense. That's why we're not doing this as a for loop, is because a for loop is a synchronous loop. And you really need to be working in an asynchronous fashion as soon as you're interacting with the page, because everything kind of has to balance and use up its own slice of the computer time. Is that a good, I mean, I don't know if there's any better way I can explain it now without getting into the weeds about what asynchronous stuff is. But hopefully that's a cool little illustration of the difference. Yeah.
What would happen if you used a set timeout, Gus?
If you use set timeout, it's just going to do it once. So timeout is basically a way to delay running. It's still an asynchronous running, but it's a way to delay running the next time, or running the function, and allow the computer to do other things and then come back and run the function at a later time. And you define how long it should wait before running the function with that number. And I think it's guaranteed to wait at least that long. It may wait a little bit longer, but it's like the next time after that amount of time has passed, it will be given an opportunity to run that function. So it's still asynchronous, but instead of interval where it's, over and over and over every single time it waits, it only waits once, runs once, and then it's done. So we could do that. Set timeout, and I'll do the quick function version. If you have no arguments to your quick arrow function, you need some empty parentheses too. So no arguments, 2 arguments, you need parentheses here. But I'll do, let's see, what is this? Tweet.inner HTML equals aha. And I will do that in 5 seconds. So I'll run this. I still have my console, that's fine. But in 5 seconds, you'll see this update. Aha. And then that's it, it's done. It's not gonna run this any more times. And even if it did, you wouldn't be able to tell because it's just gonna be setting the same thing over and over. Now, here's an interesting thing. We could do set interval. And we get our interval ID, so we could clear it later, stop it later. But we still have access to the browser. And I could say tweet.inner HTML equals no. And it changes to no. But as soon as the next interval hits, it's back to aha. And I can go no. And you can fight it. You could say, no, I want this. But it will always keep setting it back every 5 seconds because this function is running every 5 seconds. And this function says set it to aha. So the only way to stop it from, overwriting what I do is again to clear the interval. And now if I do this, it will stay. This is a lot more fun than node and math problems, right? I don't know if we could have done this without some of the things we've already learned about functions and stuff though. What's this YouTube? A commercial?
Only pay for what you need with Liberty Mutual. And
this oceanside verbo is about to become the backdrop
I don't
for
want a
unforgettable
commercial.
vacation memory.
Get out of here.
I saw it a couple years ago. They had it at the library, and I wasn't sure because I've never really been a fan of her or anything really. I was very impressed.
I'll watch it later, but
if people want to look at that later, I didn't mean to interrupt your lecture.
Well, here's the other thing about it is if we leave this playing, YouTube is going to take down our class video because they'll say it's copyright infringement. You recorded it.
No, you're not. Yeah, no. And it pasted the link before I could paste what it was so people would know to look at it later.
Okay.
But if you were interested, the song Shallow.
Well, I'll watch it later, but again,
it's not meant to be disruptive.
I would play it. I would play it in class, but we are streaming this class to YouTube. Right. So if we play a copyrighted song more than a couple seconds, we will get our class video taken down.
Yeah, no, I didn't expect you to do that anyway. I just, if anyone was interested, that's all. I'm sorry.
Okay. Hopefully YouTube doesn't take down our class video because we are spreading fake news. We're claiming that Lady Gaga tweeted a bunch of stuff that she never tweeted. See, fake, it's a fake tweet. Yes. I'm a better pop singer than Britney Spears. See, this is libel. If we printed this out and said, look at what Lady Gaga said, that's libel. It's illegal. All right, so yeah, you can do a lot with just messing with this. And this is the most basic way you can interact with the browser. This is not what React, when we get to like using React web frameworks, you're not going to be manually setting inner HTML. There's like another abstraction on top of that, which is going to be used for managing the stuff. And this is a very kind of old-fashioned and actually pretty dangerous way of doing this. Because if you made your application set things, just manually set the HTML, you can do what's called a cross-site scripting attack, where if you let somebody set their username and you don't care what their username is, or set their bio and you don't care what their bio is, and you just manually set inner HTML to whatever they decide to give you, they could set their bio to more JavaScript and then run that JavaScript when anyone looks at their bio, and then steal other people's credentials, this is a kind of hacking that happens all the time in the real world. It's one of the hardest things, to be completely sure can't happen. And this is why in your application, you probably never want to do inner HTML directly in your real application. And you definitely do not want to ever do something.innerHTML equals anything that a user of your application has given you, because then they can hack your own users of the other users of your application. So this is a lot of fun, but I have to kind of end this with like, a caveat or a warning that like, if you base your real application off of this and you have a user provided input ending up assigned to directly to the HTML in your page, that is an easy way to get your application hacked or your users hacked, which is probably just as bad. Anyway, so don't go out and write your whole capstone with inner HTML equals user input. That's what I'm saying. Take it easy, wait for the React stuff, yeah, work on the wireframes, work on the CSS, the styles, the layout, things like that. Yes. Okay, good thing I remembered to say that, because somebody would go out and write their whole capstone with inner HTML if I didn't. Okay, we've got like 10 minutes left. Let's open the floor up. Anything else that, let's see. I'm not sharing anymore, right? Yeah. What should we do? Should we just say happy weekend 10 minutes early? Should we answer any questions, or you want to see any other tricks on a website? Let me know. Oh, yeah, I've been sitting in the gloom, in the dark here. It's getting dark. More tricks. Okay. Let's see. What's a good trick? What would you want to see happen on a website? I got one. Here, we can do one more trick. Let's see. Console. Okay, I need to bring the size of this down a little bit, because I'll need to do control click on the picture.
Can you share your screen while you're doing it?
Oh, sorry. Yeah, it wouldn't be a very good trick if I'm just describing what I'm doing. Okay, we good?
Good parlor tricks, you don't show them what's going on, right? It's a sleight of hand.
Yeah, I could wait until the end so you don't know what I typed and then just watch. You can see
We
the
have to
effect.
guess
But
which card it is.
I think isn't it cooler to like see the code you type in and then
Oh
see
yeah,
that it actually
I
does
really
something?
like that a lot. Call me weird, but I
Yeah.
like it.
Okay, let's see. We have a div here. We have a div here. We have a link out inside all that. Another div outside that. Another div. Another div. Man, there's so many divs. Okay, how about this one? Or how about this one? Let's start messing with the element style. Now this over here, I'll make it a little bigger. When you are in the elements pane, and if you go to inspect right away, you can find the div you want to mess with, which is, where is it? Oops, element style. And you can make it, for example, padding left 100 pixels. And then it's gone because the picture moved, or 5 pixels. And then it shifts a little bit over, 6 pixels. Oh, it actually shrinks. Huh, a little odd. It turns smaller and moves over. This is this picture right here. What I want to try to do, well, let me see, position fixed. Huh, now it's giant. And yeah, let's see. Width. What was the original width? Let's see. Uncheck that. What's the original width here? Computed 48 by 48. Okay. So we'll set that width manually. Width 48 pixels. Height 48 pixels. Position fix. It's pretty good. Okay. Left 500 pixels. And it moves over there. Yes, we got it. Okay. So we need these 3 styles, and then we can use the left style and the top style to move the thing around. And Lady Gaga's picture will go cruise around the page wherever we want. So all we need to do now, where was that thing? Oh man, I need to find the thing. Oh, here it is. The thing I had hovered. Okay. So I need to save all of this style stuff for later. I'm going to just copy this into a new VS Code temporary document so I have a little. And then I'm going to save the class, all that stuff so that we can grab it. Okay. Now let's go to our JavaScript console and let's mess around here a little bit. Okay, what should we do? Okay, let's reload the page. So we don't need to, we can start it wherever. And I can say const pick equals document.query selector. And I'll do the same class, the same trick where we use all the classes we got from the thing to try to grab that one thing we're looking for. So that's in between everything. And this is how you construct a CSS selector again for an element that has all of these classes at once. So it's a little weird in the element if they're separated by spaces, but when you're selecting, they're all prefixed by dots and there's no spaces when it has all the same classes. Just how it works. So pick is that. We got it. Okay. Now we can do pick.style dot, and we can mess with the CSS styles right from JavaScript. So the first one, it was position fixed and width and height are 48 pixels. So position equals fixed. Oh, and then it gets big like it got. Pick.style.width equals 48 pixels. Oh, that's actually all we need to do. Cool. Just change the width back and everything scales. Now, these are the fun ones. Pick.style.left and we can move it by running JavaScript. So with that all said, we can go like this: set interval function inside here. And we will run this a lot. We'll run this every 50 milliseconds, so 20 times a second. And we're going to turn this into basically an animation that runs at 20 frames per second. Now, what should we do in here? We're going to have to do a little math. We're going to have to do a little math to make this like trace out some kind of function, some kind of path on the screen that's like a nice smooth path. I think the easiest one to trace out will be a circle. So we might let me get the marker board. Let's try to figure this out. And then we only have a couple minutes, so like, oh, this is gonna be tough. Let's see. We have 0, 0 is right here. The picture, when the picture's here, it's basically left 0, top 0. We want it to go like in a circle like this. So we're gonna want it like 200, 200 is the middle of the circle. And we're going to want this to be, oh man, this is geometry. Wait a minute. You can't see my screen, can you? Let's just jump to here. We're going late on a Thursday. You asked for another trick. All right. We're going to say this here, the top is going to be at 90 degrees, the cosine, it's something to do with the sine and the cosine. And actually, who cares like what path it really does? Let's just do something with sine and the cosine, and then it should work. Okay. So we'll do math.sin of,
Do you want to share your screen, Gus?
Whoops. Oh no, 10 seconds left. Okay. Const angle equals 0. Set, oh no, I const, whoops, let angle 2 equals 0. Set interval function 50, and we'll say pick dot style dot left equals math dot sine of angle 2 times 100 plus 200. And then pick dot style dot top equals math dot cosine angle 2 times 100 plus 200. And this should make it go in a circle, I think. And then we do angle 2 plus equals 0.0003. Let's see, that might be a slow circle. What? Oh no. Oh no, here's what I got wrong. Hang on. Oh no, okay, clear. Oh no, we're a minute over. I'm out of time. Clear interval. We need to clear our old interval. Whoops. Clear interval. Oh, come on. This one, 1481. So stop that from happening and then copy all this. What I did wrong, probably, hopefully, the only thing I did wrong is these have to be straight strings and they have to end in PX. This is how like styles work. So we need to do this little backtick trick here and wrap all of this stuff in like a little inner thing and PX. Right here, PX here. Come on, go. It's a very slow circle, but it's moving in a circle. All right, let's speed it up a little. Clear interval, 1600. Do it one more time, and we'll make it 100 times as fast. Oops. Go. Yay. So now Lady Gaga's face is going in a circle. And here's the code. I'll paste this whole thing into the table, the URL and all the code in case you want to make, for whatever reason, the face of the Twitter persons go in the circle. How cool is that? All right. Awesome. Okay.
So Gus, are you okay?
Yeah, I'm fine. I'm a little stressed out because that was a lot to do really quickly. And I can't believe I actually got it right. I've been programming a long time and somehow I remembered that the sine and cosine work like that. So
yeah, but this is for fun.
I know.
And it's very silly.
Yeah.
And now you're making Lady Gaga's head. I just want to make sure you're okay. I'm just kidding.
I've put all the code in here. You can go to any tweet you want. You might have to get the class names from the tweet itself, but you should be able to make anything go in a circle.
That's mesmerizing.
Yes. Now, the last thing I want to do is bring it to the front. So let's see.
Oh my God.
Dot style dot z index equals 99. Let's see if that works. Nope, it doesn't work. Yeah, so the problem with z index is it's tricky. There's probably some container div which is behind the other divs. So it's going to be behind the other stuff, but whatever. It's still pretty cool. Let's make it go super fast. And there's no more to the class, so you can head out whenever you want. Have a great weekend, everyone. The homework for tonight is just write a very simple function. Homework for the weekend is try to organize a program that is very repetitive into a nicer, cleaner, easier to understand program by taking code and putting it into new functions and then calling the functions instead. So it's really, they're both kind of open-ended. You know, again, it's not about getting it right. It's about, you know, getting an understanding of the context. It's refactoring, Ariel. It's a kind of refactoring. So it's yeah, it'll give you practice like understanding how functions let you tonight's homework, Alina, or the weekend. Have a great weekend, Fabiola.
The weekend homework or tonight or whatever. I don't know.
Tonight is write one function that just returns
okay, so then
true or false. Yeah.
Then the weekend homework because
yeah.
I don't.
So the weekend homework, the code has pretty much the same thing repeated 3 times.
Mm-hmm.
So there's got to be some way to take some of that code and package it up in a function and give it a name that's like roll the dice once. And then you can call that function 3 times and the whole program will get much shorter.
Okay.
So
I'll try to do that.
Yeah, come to the office hours if you.
I will definitely be at office hours.
Yeah. But we'll go into a little more detail. Maybe the assignment should have been a little clearer. I mean, I'm intentionally kind of making some of these a little like puzzles. You're really, you know, like hopefully you're still gonna get the answer, and hopefully just trying to think about it. If you understand what you're trying to do a little bit, it's make the program like 1/3 as long by not repeating the same lines of code 3 times. by taking, the parts that are repeated and putting them in a function. And then all you have to do is call the function 3 times if you've done it right. Or functions, you could put it into more than one function. It's really up to you. So yeah.
Okay, sorry, wait. So we can definitely go over that if there's time on office hours, right? Because I'm looking at that assignment.
Yeah.
Okay, just making sure. Thank you. I mean, either way, I'll be there, but yeah, this is okay.
Yeah, and it's not about getting it done. I mean, it's due on Sunday, but like, I might post an answer to it on Sunday. I don't care if like, we're not trying to like grade people on the whole point is that you try it and then you get some understanding. Whether or not you succeed on your own is fine, but like, you should get some understanding of how to do what it's asking to do, whether or not that's like something you're able to figure out by just bashing your head against it long enough, or if you give up and you see it next week and you'll get some understanding of what the what functions can do for you. The idea is it's just trying to show you the benefit of putting code into functions. That's all that there is to it. And if you get some understanding of that by next week, you don't have to solve it on your own. That's fine too. So try it. Don't worry about, it doesn't really mean anything if it's too tricky. That's fine. These are tricky stuff. These are tricky problems. That's fine. So I'll definitely give a lot more hints and maybe just some definitely more specific guidance of how to do it on Saturday. So if you're still stuck, then come to the office hours. And the most important thing is to stay healthy and to stay with it, apply consistent effort, and be able to sort of show up every day and put in a little bit, and that's what adds up. So more important than anything else is just that you sort of try to break off just a little bit every day. That's really, yeah.
Have fun with it if you can. Right?
Yes.
I have a question for you, and I'm terribly sorry. This should be so simple by now. I want to pull down the latest homework that was in Module 4, Week 6, Day 3.
Yeah. There's no Week 6, Day 4, but there is
Correct.
Week 6,
Correct.
Day 3. Yeah.
Right, and I need to get that.
Okay, do you want to share your screen? And I'll stop streaming on YouTube, but
Yeah, no, I have Visual Studio Code right now, and it just has the W6D2 still. And
okay.
I anyway.